Ford's FE engines are essentially little big blocks. They started out in 1958 at just 332 cubic inches as a replacement for the short-lived Y-block. And if you're curious about those, by the way, we've done a pretty cool Y-block build, and I'll include a link in the description for this video. Anyhow, although it has its faults, the FE is definitely a better design than the Y-block, and it even grew in displacement over the years until it finally became the better known 427 and 428 versions before it was phased out of production by 1976. But by then, the FE had already staked out its place in racing with big wins in NASCAR, sports car racing, and drag racing. And it's obviously still a popular option for powering blue oval rebuilds from the 60s and 70s. That's exactly what's going on here, but with a twist. Prestige Motorsports is building a 482 cubic inch FE with all new components, including modern stacked fuel injection and nothing that's actually a real Ford product, all for a classic Cobra reproduction. The baseline for this build is a new aluminum FE block from Carroll Shelby Engine Company. The aluminum casting is approximately 125 pounds, making it 45% lighter than an original iron block. But because of the modern design and materials, it's actually stronger. Just check out that webbing across the lifter valley tying the two banks of cylinders together. The Shelby FE block has a stock bell housing pattern and deck height, but it can handle a stroke as large as 4.375 inches. And that's the same for the cylinder bore, making displacements as high as 526 cubic inches possible. There's also priority main oiling, directing the oil to the main bearings first before feeding it to the cam, which we definitely appreciate. This block uses the stock 2 3/4 inch main bores, but interestingly, the Shelby block also uses billet aluminum main caps, which is a bit unusual. It probably will help the two bearing halves expand at the same rate once the engine gets hot versus a more standard setup where you have an aluminum block and steel main caps. The main bearings are from Sealed Power. Once they are in place and coated with assembly lube, Cody McCleary installs plastic sleeves over the main studs to protect the crank as it's lowered into place. The forged crank has a 4 1/4 inch stroke, which the block handles easily with no clearancing required. The main journals are stock FE sized, but the rod journals are Chevy Big Block Standard 2 inch 200 thousandths, which will provide more choices when choosing connecting rods. After tapping in the first 4 main caps, McCleary prepares the seal for the rear main cap. Because this is a skirted block, you not only need the main seal to keep the oil from leaking around the crank journal, but you must also seal between the sides of the cap and the skirt of the block. McCleary installs the seals into the grooves in the sides of the cap, and then for good measure adds a nice thick line of high temp silicone. After the cap is in place and McCleary confirms that the seals are completely bottomed out, all the nuts on the main studs are torqued to 100 foot-pounds. Then 2 steel spikes are driven in behind the seals in the rear main cap to make sure that those seals are fully pressed against the aluminum. Next up come the side bolts, which help significantly strengthen the bottom end. There are 2 on each side of numbers 2, 3, and 4 main caps. To keep oil from weeping past the bolts, a thin bead of silicone is run on both sides of the washers. Then the bolts are all torqued to 40 foot-pounds. The rotating assembly is made up of JE pistons on Eagle connecting rods. The forged H-beam rods are 6 inches 700 thousandths long and with a bushed end for a floating wrist pin. The big end is 2 inch 200 thousandths Chevy Big Block size like we already mentioned, with ARP 2000 7/16 inch cap screws. Meanwhile, the JE pistons are custom slugs designed to fit into the 8 4 1/4 inch holes in the block and have a 25 cc inverted dome to help keep the compression ratio down to about 10.8 to 1. That should at least keep it in the upper range of being pump gas friendly. The goal of this engine isn't ultra high horsepower, since it will already be going into a super lightweight car. Also, it'll be naturally aspirated, so the ring gaps are fairly standard. They are 22 thousandths of an inch for the top rings and 24 for the seconds. The idea for the slightly larger gap on the second ring is to allow any combustion pressure that gets past the top ring to move on into the crankcase. That may seem a little counterintuitive at first, but too much pressure trapped between the top and the second ring can cause ring flutter. So even though you don't want extra pressure anywhere, it's much better for it to be in the crankcase where it can escape out the PCV valve than trapped in between the piston rings. Once everything is together, McCleary drops the pistons and rods into the block. After double checking stretch, each of the rod bolts are tightened to 75 foot-pounds with Moly Lube on the threads. Prestige often uses solid rollers on their hot street builds, saying that you can get great performance from them. And if the engine is built right, the chore of lashing valves should rarely ever have to be done. The cam is pretty square. It has 335 thousandths of an inch of lobe lift for both the intakes and the exhausts. With 1.76 ratio rocker arms, that comes out to 589 thousandths total lift. The duration at 50 thousandths lobe lift is also the same for both at 244.6 degrees. The lobe separation angle is 110 degrees with a 106 degree center line. Larry Broker has taken over engine assembly at this point. After stabbing the camshaft into the block, he uses a cam thrust plate from Pioneer to lock the cam in place. And on top of that goes a billet double roller adjustable timing set. Once the cam has been degreed in, Broker installs the Carroll Shelby cast timing cover. Notice the sleeve over the snout of the crank. The FE engine design uses a separate sleeve like this versus an extra long snout on the crank damper. And this is also made by Carroll Shelby Engine Company for this purpose. Now we turn our attention to the oil pan. This is one of AVA's 427 Cobra wet sump pans. This 9-quart pan is extra wide so it can maintain good oil control while still only being 6 inches deep. It has multiple segments and trap doors to help hold oil around the pickup even on the most aggressive track days. And there's also a windage tray to help keep excess oil away from the crankshaft. One of the advantages of a deep skirt block like the FE is it accepts a flat, one-piece oil pan gasket. These are less prone to leaking, but Broker still applies a thin bead of silicone to help ensure 0 leaks. Then the windage tray drops into place. Notice the stud extending up from the center of the tray. That's the mount for the oil pan pickup. And by the way, we're using one of Melling's high-volume oil pumps to move oil throughout the engine. After another gasket is laid in place on top of the windage tray, the pan can go into position and be bolted down. Last, before Broker flips the block back right side up, he presses on the Innovators West harmonic damper. Here, you can see how the damper doesn't have any depth to the hub, and the steel sleeve we showed you earlier limits just how far the damper can be pressed onto the snout of the crank. Broker drops in the solid roller lifters after lubricating all the lifter bores with assembly lube on a brush. These are tie bar lifters from Howard's, so no dog bones or tie downs are necessary. Before dropping the cylinder heads on, Broker first takes a moment to screw in a pair of oil restrictors, one for each bank of cylinders. The restrictor is drilled with a 62 thousandths hole, and it helps maintain higher oil pressure around the cam journals by limiting the amount of oil entering the rocker stands. You'll be able to see it more clearly in a moment, but Prestige doesn't need as much oil in the rocker stands because they are setting up the valve train to also flow oil through the push rods and oil the rocker arms like a more modern engine. A little high pressure lube will keep the big 1/2-inch head studs from ever galling against the aluminum threads in the block, and they are gently run down until they are just barely bottomed out. The cylinder heads are Edelbrock Performer RPMs. They are unported aluminum castings, but still much better than any of the original stock castings. The decks of the heads have been cut down to get the combustion chambers to 69 cc's to go along with the 170 cc intake runners. The head has a 13-degree valve angle, and the stainless steel intake valves are larger than stock at 2 inches 90 thousandths, while the exhausts are also oversized at 1 inch 660. Maximum valve lift before the springs go into coil bind is 600 thousandths of an inch, which is just enough for our valve train with 589 thousandths valve lift. Broker slides the heads down over the 1/2 inch studs onto the block. With lube on the threads, they are tightened to 100 foot-pounds in 3 steps. Here, you can get a better look at the intake runner path. As we already mentioned, the goal of this build isn't to produce world record power. The owner wants a strong running engine with great throttle response and plenty of torque throughout the RPM range, as well as tons of power. So the heads haven't been ported because as cast, they are plenty capable of hitting Prestige's 500 horsepower goal. With the heads in place, Broker lays down a set of Fel-Pro intake gaskets and applies a thin bead of silicone around all the ports and a thicker bead across the China rails to make sure everything stays down nice and tight. Normally, the rest of the valve train, the push rods, the rocker arms, and all that go on next, but that isn't possible with the FE design. With the FE, the push rods actually route through the intake manifold, so it has to be installed first. At this point, there are no bolts in it yet. Before anything gets bolted up, Broker mocks up the distributor, making sure it is fully seated. This is a great tip because FEs are bad to blow oil past the distributor seal if it isn't perfectly seated. So make sure that the distributor is in nice and square and then bolt the intake manifold down tight. And now that the intake is in place, a quick coat of extreme pressure lube on the ends of the push rods is all that's needed before they can be dropped through and seated into the lifter cups. Prestige is using 3/8 inch diameter hardened steel push rods with an 80 thousandths thick wall. The intakes are 8 inches 900 thousandths long and the exhausts are 100 thousandths shorter at 8/800. The FE engine design uses a shaft mount rocker system. The original system oiled through the rocker shafts and used solid cup push rods. That system would use adjusters like you see on the left. Broker swaps them out with cup adjusters, that's them on the right, so we can run conventional hollow push rods. Besides installing the new adjusters into the push rod side of the rocker arms, Broker also rearranges the spacers to move the intake rockers further apart. This is because the larger intake valves Edelbrock uses in the Performer RPM heads require the valve locations to be adjusted. So the rocker positions on the shafts should be moved to match in order to achieve the best valve train geometry. Because it's a shaft mount system, all the rocker arms have to go on at once. This is a 1.76:1 ratio setup from Harlan Sharp with aluminum rockers. The fulcrum of these rockers is bushed, so they will be provided a steady supply of oil that's fed through a gallery in the cylinder head, through the rocker stand and into the shaft. That's the one we showed you Broker screwing the restrictor into earlier. The push rods are hollow and also provide oil to each rocker arm for additional lubrication. Broker slowly works the entire rocker assembly into place, running each bolt in a little at a time before coming back around. If you simply crank down on one corner and start working your way across, you can potentially bend the shaft and ruin the rocker assembly before you even get a chance to fire the engine. Once everything is finally snug, Broker torques the rocker stand bolts down to 35 pounds. And lashing these bad boys can be a bit tricky. Remember, this is a solid roller. With a 10-inch 150 thousandths tall aluminum block and aluminum heads on top of that, it's going to grow a lot once it warms up. To account for this, Broker runs the lash all the way down and then tightens the adjusters. Once the engine fires up and gets warm, the lash will open up and they will dial in the hot lash then. Now let's talk about this intake manifold. You've probably already noticed there's no central plenum like a conventional intake. That's because this is part of an individual runner setup from Borla Induction. In order to run properly, individual runner systems like this still must be able to communicate between the cylinders. To do this, the Borla intake manifold casting has small lines from each runner that leads to a hidden chamber, or some people call it a plenum. The crosstalk that's allowed through this plenum smooths out the intake pulses and helps the engine run more smoothly. The four beautiful throttle body assemblies are sized at 48 millimeters, and as you can probably tell, they're designed to mimic classic Weber carbs. Really, I just love that canted in look, and the fuel lines will be run on the inside to keep a really clean appearance. That wheel you see in the center of the intake is Borla's capstan style throttle linkage. And all 8 butterflies will open on the same ratio. That center plenum chamber we spoke of earlier allows the map sensor to be mounted low and out of the way on the intake, and the throttle position sensor is mounted on the rearmost throttle body to help keep it hidden. On the dyno, you can see the Billet Specialties TrueTrack serpentine system has been installed to spin up the engine accessories. And here you can also see how the fuel lines are plumbed up to the inside of the throttle bodies. All the engine management is handled by a Holley Terminator X ECU. So let's pull the handle and see what she can do. Prestige ran the 482 FE from 3,500 to 5,800 RPM. The 573 foot-pounds of peak torque came on at 4,100 RPM, and peak horsepower was 501.6 at 5,400 RPM. Best of all, the engine pulls strong all the way through. This engine should be a blast to drive on the street or even a track day. Average torque throughout the pull was 529 foot-pounds, which means the driver should be able to burn rubber with no more effort than simply mashing the throttle. Plus, you gotta admit, those canted throttle stacks just look wicked. Hey, thanks for watching. Please subscribe and we'll see you next time.